Hello everyone, my name is Jenny Gardner. I'm an academic coach here at SNHU. Welcome to this guide on domain and range. We will begin with definitions, then we're going to move on to your options for solving domain and range, and then finally some examples. So here we go. We're going to start with recalling what a function is, because domain and range is all about a function. A function shows you what y is doing, that's your output, the end result, when you have changes in x. So y is the function of x, f of x. How x is behaving determines your y. So what is inputted into x will show you what y, the resulting y will be. So when we think of domain, that's your input values. Domain are your x's. So if we think of a graph, the x-axis is horizontal, left to right, and the y-axis is up and down. So if you have some sort of graph happening, then you can see that x is doing something as it goes from left to right, x is moving upwards, and then what is y doing as a result? Well, y goes up, then y goes down, then it goes up again. So x is the input. You can see what you're inputting in x shows you what's happening with y, because y is the range or the output. So domain is x from left to right, all the things that can be inputted into the formula, and range is the output or the vertical, what's happening as a result. So how do we find it? Well, there's a couple things that help us. First, you can graph it. Visually, you can see all the possible x's and y values of the function. But you have to remember that a graph graphs all of the options. So if you have anything logically that needs to be included, you must think about that too. And we'll talk about that in a second. You can also solve by calculating. There's a few rules that help us find domain and range through calculation. So remember, something to think about is that denominators cannot equal 0. The bottom of a fraction cannot equal 0 because you can never divide by 0. That can never happen. Nope, not happening. So you can't divide by 0. So anything that is on the bottom of a division, like if there was x plus 2 on the bottom, then x plus 2 cannot equal 0. And that helps us figure out what x cannot be. And we can help figure out what the domain is from there. Additionally, the shape of a graph helps you figure out things too. If you have a parabola, that's when you have something with x squared in it. If you have a parabola, then it's going to make a U shape. So at some point, it stops on the y-axis and does not go further downward. So if it stops on the y-axis, then that helps you determine the range. Anything above the vertex or the bottom of the parabola where it opens, anything above or that point, or if it's facing downward below that point, will tell you what the range can be and what the range cannot be. So they cannot equal 0. The parabola can help determine the range, or different shapes of graph can help determine your range, but logic is helpful too, as I mentioned before. If you have money and you're saying that you were determining if you spend a certain amount of money, how much something would be, well, money can't be below 0. You're not going to spend a negative amount, so that's not helpful if you have a negative input, and so therefore that can help you determine the range. If you can't be negative, you can't be negative, and you say logically we cannot be negative in this, and you move on from there. Another thought is weight. Weight is not below 0 either, so if you're determining something about the weight of a car or the weight of a person, people don't weigh below 0, cars don't weigh below 0 unless we're talking about some other sort of gravity that's not on Earth. So when thinking about that, it helps you determine logically if that part of the graph can exist. And that is crucial, that is very crucial to both the domain and the range, depending on what those mean, because X and Y are not just letters. X is a variable that means something, and Y is a variable that means something too. So when you apply this to real-world information, use logic. So we're going to look at this information here. First of all, calculating the domain. Calculating the domain, our x's. What can our x values be for this problem? Is there anything limiting what x can be based solely on this formula with no other information given? Is there anything that's limiting what we can put in for x? Think about that for a second. And no, there is not. You could put any number. You could put a -1,000. You could put a 100. You could put a 0. You could put any number you wanted into this formula and you'd be able to have an outcome. And try it out, absolutely try it out and see what happens when you put those values in for x, every x. So you can put it here and here. And you will find that it does output some information, which means that this has no limits on the domain, on the x values. So this goes from -infinity to infinity. And you'll notice I used parentheses because infinity is not a stopping point. It continues on. And when we have a stopping point included, we would use a bracket. But when we do not have a stopping point included, we would use a parentheses. So next, let's look at the range. The range is the y values. So this is the outputs. Well, this is a polynomial with x squared, which means this is going to be making a parabola, which means at some point here, it's either opening upwards or downwards like this. But when it's opening upwards or downwards, we're going to be seeing that it has to have some place that it starts. Some point where it begins, and from there, it has a graph upwards. But in this case, it doesn't have a graph downwards at all. There's nothing there. And so since there's nothing there, we do not include that as part of our function. It's not relevant. So we have to look at what the vertex is. Well, the vertex, the point where it begins, is at C. And if we look up here, that point is at -10. So we have a value where at -10 and above, this will begin. And so when we do our graph, when we do our range, we could say it starts at -10 and it goes upwards to infinity. And it continues upwards from there. And if we're ever in doubt, we can graph it. And so let's try that. Let's try graphing it. Desmos is a lovely graphing calculator that you can use, desmos.com. And I'm going to type this in, 16x squared plus 3x minus 10. 16x squared plus 3x minus 10. And if we look here, it does open upwards, like we said, opening upwards here, and it begins at the -10 spot. If I scroll in, you'll see it begins there, the vertex, it's at the -10 spot. Okay, so we have that lovely point, and we see that it opens upwards from there. So we are able to then look back over here and know that our range is from that point onward. We have another example here, and it's important to think about this example too, because we're going to have sometimes where our domain is limited, where our x values are limited. So remember, we're looking at x first. And so on this one, we have 3x minus 4 on the bottom when we said this cannot equal 0. So that means there's going to be some x's that can never be true. Maybe 1x, maybe 2x, depending on how many you have on the bottom. So in this case, 3x minus 4 cannot equal 0. Well, let's solve what x would be. If we move the 4 to the other side by adding 4 to both sides, we would have 3x equals 4, and therefore x equals 4 over 3 when we divide the 3 over. So x can never be 4/3. And so our domain cannot include that. So what would happen is that we would go, whoops, hold on. Got to put the correct symbols, guys. All right. Goes from -infinity all the way to 4/3, but it cannot be 4/3, so we have a parentheses. And it goes from 4/3 to infinity, but it will not include 4/3 at all. So it does everything but 4/3, and this is how we would note it in interval notation. If we were looking at figuring out the range, we have to find the inverse first. And if you don't know how to find the inverse of a function, I would suggest going and looking that up and figuring that out and looking through that as well. But in this one, I want to focus on the range. So we have the inverse found right here. And so this is the inverse of the function. And now that we have the inverse of the function, we have to think, well, what does this tell us? And so looking at this, we have 3x minus 16 can never equal 0. And if we add our 16 and divide by 3, we see that x cannot be 16/3. But since this is the inverse, we could say y cannot be 16/3. And so when we're looking at that, y cannot be 16/3, and therefore our range, our y values, would have to avoid 16/3 as well. So the -infinity to 16/3 and 16/3 to infinity. But because we have the parentheses there, this tells us that it does not include that number. It includes everything but that number. So now that we've done that, you can definitely graph it and double check it on your end and see how that works out. Okay, try it out, look at your graphing, try out the graphing from before as well, and these problems, and feel free to rewatch. Congratulations. Thank you for watching the Academic Support Guide on Domain and Range. Please read the video description for further resources, and be sure to check out any concepts you didn't know and rewatch, relearn before you tackle new things. Thank you so much for watching. Have a marvelous day.